We want to start off talking a bit about the JP3 analyzers, and more specifically a little bit. And I apologize to some of our colleagues that are here from the US. We're going to focus a little bit on condensate measurements in Canada because there's some specific pipeline things that need to get done here. And we want to talk about how to optimize condensate production. Because that's really, as far of all the natural gas liquids or natural gas oriented products, whether it's pipeline quality sales gas, natural gas liquids like Y-grade, and condensate. Condensate's the big value one. And especially for some of the fields that we're developing up in Canada right now, up in the Montney, there's a lot of liquids production with that. So we want to talk about how to make the most out of that liquids production. Because there's a lot of value towards the optimization. If we optimize the operation on the condensate stabilizer side of things, here, this again, we've got that inlet separator part, right? We're going to take that hydrocarbon liquids that's coming off of that inlet separator, knock out any water and feed that over to the water side, and then move it over to the stabilizer. And at the stabilizer, we're going to be trying to separate the parts that we want to keep as liquid and the parts that we want to go to further on into the plant to be treated on the gas processing side. And the trick to that, as we mentioned earlier, is to adjust the temperatures and pressures accordingly. The important thing to realize is how much value there is in adjusting those accordingly. If we can set the right operating conditions for the condensate stabilizer, first of all, we can make sure that the product that we're going to produce is going to meet specifications. And that's a big part of this whole thing. Talk a little bit about pipeline specifications and allowable butane contents, etc. But from other perspectives, when we can optimize that operation, we optimize our product volume. We produce more barrels of liquid. Again, most valuable product that's coming out of a gas processing facility. We also push less gas to the overhead side, which minimizes the amount of energy we need for recompression. So in current times, especially in Canada with our left-leaning government, there's a big thing about CO2 emissions and energy usage, right? And so when you can optimize your compression and minimize that energy usage, it also lowers greenhouse gas emissions. Most often when we optimize a stabilizer as well, means that we're going to put less heat into it. We're going to actually not reboil. We're certainly not going to overboil it. And so that can minimize our energy for reboiling, which again reduces emissions. But the most important part of it is we can maximize revenues by maximizing dollars. This is really where the big money is to be made. And if we don't do it properly and we produce off-spec product, there's penalties at the pipeline side, and that's where the big money is to be lost. So the value of doing the analytics properly in this application is that you can try to maximize your revenues and minimize penalties and minimize emissions all at once. It's really a win-win-win kind of thing. So if you can increase your production even by a couple of cubic meters a day, by 13 barrels a day, you suddenly get to print an extra $1,000. So this opportunity to optimize is a direct impact on the cash flow, because if your operating costs stay the same or actually get less because you're burning less energy, this is a direct impact on cash flow and profitability. First, I want to talk a bit about kind of what are we really doing in the optimization? So when we have a condensate stabilizer, depending on whose pipeline it's going to go through, there's going to be various specifications and requirements. The job here is to boil off the light ends, the part that the end user or the pipeline company doesn't want, and try to keep the heavier stuff that they do want in the liquid side. So, raw condensate or field condensate will come into the tower as a liquid. It's recirculated and heated. There's a distillation process going on here. So the light vapor ends go to the overhead, and the saleable liquid, this is the stuff that we're going to try to push out to the pipeline for dollars, comes out of the bottom end of the stabilizer. The question is have we optimized the dollars and does it meet all the specs? And it's important to know that if we were to overboil the condensate, suppose we're coming in with a total of 106, this is a simplified case, by the way, but suppose we're coming in with a total of 106 barrels of liquid. 98 barrels of it is C5 plus, it's the stuff that for sure we can sell at condensate, and 8 barrels of it is stuff that is the butane. We're allowed to have some, but not too much. If we overboil, if we cook this condensate too much, what happens is we push more of the butane up onto this side. So the example we've used here is they've boiled it down to the point where they're only at 2% butane. So then they would have approximately their 98 barrels of C5 plus, 2 barrels of butane, a total of 100 barrels. Did this slide when prices were really low, so at $20 a barrel. Right now, it's more like $70 a barrel. So let's just make a little change here. $70. That 100 barrels is now worth $7,000. So that's all well and great. But now what would happen if I actually made a measurement there and said, oh, I've got room. I'm allowed to have 5% butane. I'm allowed to slip more butane to the bottom. So I'm going to lower the amount of heat that's going into here and see if I can optimize that number. So if I put an analyzer in there to give me some control on that bottom end, on how I'm controlling that stabilizer, again, we'll do it with the new pricing. Now I can get that up to 103 barrels, 3% more product. So great, I have to do the math in my head now. 103 times 70 is now $7,210. I was $7,000 before. I just got this extra $210 by lowering the amount of heat, lowering the energy consumption of my condensate stabilizer and optimizing. So our point here is that by controlling the process better, we can both use less energy and produce more product and make more money. There are people out there that say, "Oh, you don't have to do the measurement. There's enough process data already. You've got pressure transmitters and flow transmitters and densitometers, and we can do some data fusion kind of thing and build you a model which is going to tell you what the operating set point should be." And all of that works as long as you're doing labs every day constantly, because as soon as feeds or ambient temperatures or plant load changes, those models tend to fall apart. Requires far more lab data and consistent modeling and yearly subscriptions to software development rather than just putting in what you really need, which is measure the composition. And we've proven this works across multiple facilities. A major midstream producer, almost every drop of condensate that moves through Canada touches these people's pipelines. They had a full gas chromatograph online vapor pressure analyzer. Extremely well done systems integration, big custom shelter, redundant filtration, all kinds of things to keep it up and running. They'd had it running for years and they came to us and said, "We want to try this another analyzer on here because while what we're doing works, Our maintenance costs and effort, we have one full-time person whose job it is to keep those analyzers up and running. And we go through over $50,000 a year in spare parts and carrier for the GC. Put an analyzer in them about 5 years ago, again, 5 years in service. Very low maintenance. They've now put it on every one of their condensate lines. A gas plant in the Montney, they had new GCs, relatively new. They had bought them about 3 years ago when we started talking about them. For 2 years, they've been trying to get them up and running on their condi. They had gone to the local distributor. They had gone to the US Sales and Service Office. They had spent over $200,000 in factory service on these analyzers that they had bought and still not up and running. We replaced them with this technology in January of this year. Within 3 months, they're full up operational and they're optimizing their stabilizers. So remember, if we're talking about a stabilizer that they can increase by 6 cubic meters a day, it's $90,000 a month. In 3 months, it's potentially paid back $250,000 already. So what is the solution I'm talking about with this JP3 things? We apply near-infrared spectroscopy to doing these measurements. Instead of using chromatography or some other technique, we shoot a beam of light across the sample. Insight's the local distributor. JP3 is the original equipment manufacturer out of Austin, Texas. The big advantages are no moving parts. Everything runs through half-inch tubing and piping. It doesn't plug off very easily like the eighth-inch stuff does. Fully capable of monitoring multiple streams in a facility. Very fast analysis, near real time. It can get down to be as low as about 15 seconds for a data update. Virtually no maintenance. I mean, having no moving parts and large diameter tubing eliminates a lot of the maintenance issues. Cell modem and cloud enabled, we can do full support of the analyzer's operating health and conditions via the cloud. And we run field support out of Grand Prairie, out of Edmonton, and out of Calgary.